All right, we're going to finish up our discussion about operating systems and command line environments. Just to take you through a tour of what we did, we talked about software. This is coming off of discussing hardware. Then we went into free software and the free and open source software movement. We talked about Apache and some other things. Levels of software, so we talked about firmware, assembly, compiled languages, and interpreted languages. We said that compiled languages are low level, like C++ and Fortran and so on. And interpreted languages are high-level languages that are like R and Python and so on. Another one that we're going to meet in just a little bit is called Bash, or the Linux command line. Operating systems, we said that there are many operating systems that are out there. They generally break down into three categories. There's Windows, Mac, and Linux, and we said that Linux is not just one operating system, it's actually many different operating systems. These are built on top of the so-called Linux kernel, and there's kind of this specialistic chaos of different Linux distributions that are out there that go by the names of things like Debian, Ubuntu, Fedora, and so on. There are also specialized operating systems for servers, like Windows Server, Ubuntu Server, and so on. We talked a little bit about the Linux history, how it was developed, and what it means to be a Linux system or a Unix alike. We talked about distributions, and we mentioned a number of them, just like I just did a moment ago. We stopped here at the command line interfaces. So people usually associate computers with graphical user interfaces, right? This is the idea of Windows itself. When you actually open up a system, you don't just get a text-based interface, you actually have a graphical interface. So that's where the idea of Windows came from, where you have actually some kind of graphical interface with the machine, and you have a mouse, and you can kind of move that mouse around. And we take this for granted so much these days that it's so natural, but there was a time when these things didn't exist. And Windows, of course, refers to like the little panes that you move around on the screen, and there's software that actually manages those. That kind of thing is generally called a graphical user interface, or a GUI. GUIs usually use Windows, mice, and that kind of thing to interact with the machine. And nowadays we use touch interfaces all the time through things like tablets and so on. But an operating system doesn't actually need to provide that visual set of windows to interact with. Those are resource hungry. They're going to take up a lot of memory and compute resources of the machine, so a lot of servers don't have them. Whatever the case is, operating systems will always have a command line interface that is text-based. You should think of the command line interface as directly interacting with your operating system. Different operating systems will have different languages, but they generally have a family resemblance. And again, we're going to fall into that duality of there's Windows and there's everything else. And the everything else is a Unix-alike. Now, that's not to say that there aren't other operating systems that are out there. There are, but the ones that you will actually encounter are Windows, and everything else is going to feel very much like Unix or Linux. So how do you actually interact with those? That's where a terminal comes into play. By terminal, we basically mean a keyboard and a monitor. Nowadays, we're actually running these typically through a operating system where you already have Windows and so on. So you don't actually just have a terminal directly, you have what's called a terminal emulator. This is a program that's on your machine that's actually kind of playing the role of that terminal. So it'll kind of make you feel like you're in some old system where it's all command line interface, or it's all just kind of text-based. But of course, that's almost always a fiction for the way that we're actually using our computers. These programs go by different names. So on Windows, it's cmd.exe, and then you can run something called the Windows subsystem for Linux. I'll talk about that in just a little bit to get a different kind of shell. On Mac OS, there's one called terminal.app. I'll talk about some others in just a minute. And then all Linux machines will have terminals natively associated with them. It's very common in a terminal that you actually want to break up the screen even further with something called a terminal multiplexer. You can think about this as kind of having that window that's serving as that terminal emulator. So it looks just kind of like a text-based command line interface, but then you want to break that thing up even further into different windows, but all of that interface is all text-based. So this can be simulated with a terminal multiplexer, and the common ones that you'll meet here are called GNU Screen, or just Screen, and Tmux. So now onto the shell. What is the shell? You should think of the shell as a kind of command line interpreter, which is going to allow you to speak directly to your operating system, okay? Directly to your operating system's services. So it's a program that's going to sit between you and the operating system and interpret commands. So in the same way that when you open up RStudio and you're typing things in the R console, when you push enter, the R interpreter is going to interpret that command that you just gave it, it's going to evaluate it, and it's going to print it back. And the shell is going to play a similar role for things that the operating system does. So it can do basic calculations, but it's not usually for calculations. It's usually for telling your operating system to do things like make a file or move files or things like that. We're almost always going to associate shells with Unix, but Windows does have one. It's, as I said, it's called the Windows Command Line, or cmd.exe, and it's kind of by default what's going to open when you open up one of these command line interfaces with Windows. I'll have to talk about that in just a little bit. Now, going back to that aspect of shell as interpreter, people usually use this term pretty vaguely. So they could use the term shell as the interpreter itself, or they could use the term shell as like the language that you're specifying, very much like R. So with R, the program that is the interpreter is often referred to as R, but also the language is R, right? And the same thing is going to happen for the shell. But there's all sorts of names that people could refer to this as. So you'll hear things like the command line interface, or sometimes actually just a specific shell, like bash or something like that. I've already done that once this particular lecture. As I said, there's this analogy with R and the R language that I think is pretty helpful. Notice this acronym at the end, REPL. That stands for Read, Evaluate, Print Loop. And that's exactly what any kind of shell or any kind of interactive programming language is going to give you, right? There's kind of a prompt, and it's saying, enter something here. And so you type in some code, and you push enter. So that's read. Now it's going to evaluate the commands that you just gave it. It's going to print out output, and it's a loop. So it just keeps going forever, right? After you push enter, you get another prompt, and you push enter, you get another prompt, and so on forever. The original Linux shell was the Bourne shell, and it's on a command line, it's actually just called sh. And now, obviously, it's very old, and almost nobody uses sh, but it is actually in the machine, and the machine itself will run it fairly frequently, which is kind of surprising whenever you see it used. But people aren't routinely using the Bourne shell. A number of shells came after this. The Korn shell KSH, you'll notice these not by their name in the future. You'll see them in the Linux command line itself, okay? So SH is always going to refer to shell something, okay? KSH, the Korn shell. Born Again shell, BASH, Born Again shell, which everybody just refers to as bash, okay? And this is the default shell on many different common operating systems, okay? So bash is kind of considered to be a more or less modern standard of sorts. It will be always kind of available to you. Z shell or ZSH, this is going to be a further extension of bash, bash being an extension of the original Bourne shell. And it is in very common use. It is now the default on Mac OS, or it's kind of like what Mac OS will recommend. So once you open a terminal on a Mac, it's going to recommend you change your shell to the Z shell immediately. You can customize this with a application of sorts. I'm not exactly sure what the right term is there. It's actually just a set of configurations that are referred to as OhmyZSH, and it's very easy to install once you're used to ZSH, and it makes the shell look really nice. So if you've ever seen somebody working at the terminal and it looks really cool, probably what's happening is that they have customized the terminal in a particular way just to give things colors and so on, default printing, and that is done with customizations that are like OhmyZSH. It may not be that, but it's usually something that's very close to that. There are two that are very close together, two kinds of shells that are very close together that you will see occasionally, but you won't use, and they're called the C shell, and I've never actually heard this pronounced before, so I'll just say TCSH. And the shells themselves, as you can imagine, they're programming languages, just like R is. So they have all sorts of things like loops and variables and all that kind of stuff. And the syntax for those, you'll have to see. And so you'll see these in the coming lectures and discussions. But they can vary according to the shell that you're using, which feels a little weird, that the shell, as you're speaking to your operating system can kind of speak like different dialects almost of that language. So like the for loops could look really different. These two shells, CSH and TCSH, their syntactical structure looks a lot like the language C. And so a lot of the code there is not actually interoperable with most shells, which is actually different from the others. So if you're coding in ZSH or Bash or just the shell itself, a lot of that is the same. You know what I mean? Like you define variables the same way, you access them, and for loops and things like that. Okay, they're almost all the same. There's little variations, and those can be important, but generally speaking, they're the same. You know, you could generally refer to all of them as just Bash. But CSH and TCSH actually are quite different. And when you see them, you're not going to think that it's shell script. Okay, so just be mindful of that. Okay, there's a comparison on Wikipedia of command line shells that I think is really useful. I'm not going to go into that, but you have these slides, so you can kind of click on that and you can dig into it a little bit more. I want to take a moment to talk about accessing the command line a bit more. Just because this is a really important topic and it's really bumpy at the beginning, unfortunately, mostly for Windows users. So to open up and get access to a command line on a Linux machine, you're just going to look for an app called Terminal. Every Linux distribution has an app called Terminal. It's built in. Just push your super button and type in Terminal, push enter, and you're going to get a terminal. For Mac OS, this is also built in, but it's maybe a little bit more challenging to find by 10 seconds or something like that. Open up your applications directory, or you can push command spacebar to open up Spotlight, and you'll just type in terminal.app, and you'll push enter, and you'll get a terminal emulator just like Linux provides. Now, most Mac users don't actually use terminal.app. I don't know what it's like for different Linux users. Linux users usually, there's kind of, again, this kind of specialistic chaos where people have their own customizations that they like. On Mac OS, it's very common to see people use the terminal emulator called iTerm2. And actually, it was iTerm2, and then it kind of went back to iTerm1. Just Google it, and you'll download it actually from the website, and there's a lot of customization that you can get using iTerm. On Windows, Windows is more challenging, of course, because Windows comes with a default shell that is not the same kind of like Linux command line that we're interested in having. Nevertheless, there are many different ways to open a terminal emulator on a Windows machine. There are probably 3 programs that you can think of that do this just by default. Probably the easiest one is just the command prompt itself. Just push the Windows button, type in CMD, push enter, and it'll be open. Okay. And you're getting kind of this interface to a DOS style shell. And these commands are going to be very different than the Linux command line. And you'll know that they're different because if you look to the prompt itself is always going to say something like C:/ whatever the weird delineator stuff that Windows has. Okay. Now, there are 2 other kinds of prompts that you can get to. One I list here, it's called PowerShell. And I think that a lot of Windows users who do shell stuff work in the PowerShell. So this is common for Windows administrators, for example, sysadmins on Windows servers and that kind of thing. There's also one called Windows Terminal. You would just go into the App Store, and you may have to install it. A recent Windows install of mine had it installed already by default. So and then in that customization, you can tell it that that's the terminal emulator you want. Okay, you're not really going to get differences here that are really substantial because you're not going to be working the terminal directly in a terminal emulator that's distinct from RStudio almost ever. Okay, nevertheless, it's useful to know that those are out there. So how do you get a Linux command line on a Windows machine? This is the really kind of important point. Okay. There are at least a few different ways to do this. I'm going to describe one, and then when you see Docker, you're going to see essentially like another one. The Docker one is probably the one that we will learn most on, but when you're actually doing stuff out in the wild, you're probably just going to use what's called the Windows Subsystem for Linux, or WSL. Okay, so here's how you're going to do that. You're going to open up that DOS shell that I was just talking about. Okay, so just push the Windows button, push CMD, press enter. Okay, then type in WSL space -L space -O and press enter. What that's going to stand for is WSL is the Windows Subsystem for Linux. Okay, it's not going to be installed yet, so you'll see this when you do this. When you push -L, that's going to say list the options, like the options for the different Linux distributions that you can install. And you'll see that there's roughly a dozen, something like that. So there's going to be like Ubuntu, there's going to be Debian, there's going to be older versions of Ubuntu, there's going to be SUSE, there's going to be Kali, and so on. There's a number of these, okay? In any event, you'll install Ubuntu with WSL space dash dash install space dash D, that stands for distribution, space Ubuntu, okay? You'll push enter, and hopefully if everything goes to plan, it will just take a little while to actually like install the components and so on that you'll need to actually run this, okay? If it doesn't, go ahead and just click here, or you can Google Windows Subsystem for Linux install. One of the nice things about this actually is that Windows has done a good job with this. If it fails, it will fail and it will tell you a website that you need to go to, and that's either this website or it's a website that's very similar to it if you're kind of installing kind of just standard or using this kind of manual way to install. In any event, that's a very helpful thing to do. So don't be surprised if this fails the first time. Just install it again, run through that little list, and it's probably a simple little fix, okay, where you have to kind of copy and paste a command in, and then it all works, okay? In any event, after you install the Windows subsystem for Linux, it will actually put you into Ubuntu by default because you just installed Ubuntu, and it's actually going to open up that program when you install it, okay? You can exit it by typing in exit, and then when you want to reinstall, when you want to enter into it in the future, you don't type in WSL again, you'll just type Ubuntu, okay? Just by opening that command line, type in Ubuntu, and then you're there. As I said, if you want to use Windows Terminal, you can do that from the store. And one of the nice things about the Windows Terminal is that you can have different shells in different tabs. And so just like a web browser has different web pages, here you'll have different shells. What about in RStudio? RStudio actually has a terminal pane. And this is the way that we're actually going to get familiar with the Windows command line. So it's going to feel very much like R, where you have a scripting window and you have a console and so on, and you send commands back and forth. Same thing. However, it's not going to be R. So we're going to be sending these commands that are Linux commands from the scripting window into the console pane. So it'll be helpful to have a Linux terminal in RStudio. And what's nice about that is that if you go into RStudio, next to the console tab in the console pane, you'll see there's something called terminal. If you click on terminal, it will actually open up your system's default terminal. So if you're on a Ubuntu machine, that's going to obviously be Linux-alike. If you are on a Mac, it is either going to be Bash or ZSH, just kind of depending on your system configurations. But either of those are Linux-alike, and so these are the kinds of shells that we want, right? Again, the challenge is Windows. So on Windows, you can actually get one of these shells. What you'll do is you'll need to install that Windows subsystem for Linux first. Then you'll go Tools, Global Options, Terminal, and now you can actually say how you want new terminals to open. So there's just a drop-down menu, and click New Terminals Open with the Windows subsystem for Linux, and it'll probably say like -bash or something like that. Okay. On a Mac, if you want to do ZSH, that's how I usually configure my machine. So I encourage you to do that. Alternatively, you could actually run Linux from a virtual machine or a container. So if you install VirtualBox, like I'll describe in the next part, you could just actually virtualize a whole Ubuntu machine and work from there. I don't think that's a really efficient way of doing it, but it's something you could do. As an alternative, you could containerize things with Docker. I'll talk about this as well. However, Docker is going to be kind of a different path here, which may actually be a better path for you kind of in a longer term. Certainly, we're going to be learning through it. In a longer term solution, it's not clear, will you be using your Windows subsystem for Linux, or will you be using a containerized version which has more of your own kind of customizations for whatever the setting is you're in. That will kind of be a 50-50. So I'll go ahead and stop this video, and then we'll move into virtualization, containerization, and maybe some cloud computing.